Alright, so now we're going to take a look at how to calculate net force. So more than one force can act on an object at any time. The forces can push or pull in any direction. What happens to the object when the forces act depends on two things: how strong the forces are, and forces are measured in newtons, and also the direction of the forces, so which way they are pulling and how strong. When more than one force acts on an object, the forces combine to form a net force. The combination of all forces acting on an object is net force. So that's what we're going to be calculating today. Forces work in pairs. Forces may work together, or they may be opposite forces. Two or more opposite forces are balanced forces if their effects cancel each other and they do not cause a change in an object's motion. If two forces of equal strength act on an object in opposite directions, the forces will cancel, resulting in a net force of 0 and no movement. So whenever you have a net force of 0, the object is balanced and there is no movement, so there is no change in motion. Remember, unbalanced forces can cause a change in motion. So they speed up, slow down, stop, change direction, things like that. Alright, so here is 30 newtons pulling to the left and also 30 newtons pulling to the right. So this is where you have to subtract because they are going opposite. 30 minus 30 is 0, so the net force is 0. Therefore, this particular example is a balanced force. If the effect of the forces don't cancel each other, if one force is stronger than others, the forces are unbalanced forces. Unbalanced forces cause a change in motion, speed, and or direction. So here is our next example. 30 newtons to the left and 50 newtons to the right. Alright, so the first thing that we determine is that these forces are opposite, therefore we have to subtract. 50 minus 30 is 20 newtons, and how do you know which direction it's going to go? It's going to go in the direction that has the strongest force. So this is going to go 20 newtons to the right in this direction. Okay. When two forces act in the same direction of an object, the net force is equal to the sum of the two forces. So here is our example. Here you have 25 newtons going to the right, and you also have 15 newtons going to the right. So 25 plus 15, that should be actually 40. So I'm just going to change that to 40 right here and make that a 15. Alright, so the net force is going to be 40, and it's going to go to the right to follow where the forces are already pushing or pulling. When two unequal forces act in opposite directions on an object, the net force is the difference of the two forces. So here you have 30 minus 20. Alright, it's going to go 10 newtons to the left, so it's going to go in this direction because 30 is greater than 20. Alright, the final force and its direction are called a resultant. So go ahead and fill in whether you will need to subtract or add in the following situation. So I'll give you about 30 seconds. Alright. Two forces acting in opposite directions. So I always say opposites attract. So now I'm going to say opposites subtract. This is going to be subtraction. Alright. Two forces acting in the same direction, where you're going to add because they're going in the same direction. Two forces acting towards each other. So a lot of kids had some misconceptions about this particular image yesterday. These are pushing towards each other. However, this person is pushing to the left while this one is pushing to the right. So these are opposites. So this is going to be subtract again. All right, so let's do some problems. I'm going to move this down a little bit so that we can see the full page. I'm going to let it focus, and it looks like we're ready to go. All right, 30 newtons to the left and 15 newtons to the right, where these are going opposite. So we have to do what? You should have said subtract. 30 minus 15 is going to be 15 newtons. Did this have any change in movement? Well, it did, because the net force is greater than 0, so this is going to be unbalanced. And it's also going to move towards the bigger force, so it's going to move to the left. And your teacher may want you to write the word. Let me refocus here. Okay, come on. There it is. All right. So your teacher may want you to write the word. If she does, please write the word left instead of the arrows. All right, number 2, 25 newtons to the right and 15 newtons to the right. These are going in the same direction, therefore I'm going to add. And 25 plus 15 is going to be 40 newtons. Make sure you include your units. This is not a balanced force because the net force is greater than 0. And if you forgot, please refer back to the top of the handout. This is going to be unbalanced, and it is going to move to the right. All right, so here we have multiple forces acting together. All right, so the first thing that I recommend to do is to add these two forces together. All right. 15 plus 15 is 30 newtons. I'm just going to write it on top right here. And so now I have 30 newtons pushing to the right, and I have 40 newtons to the left. Well, these are opposite, so I have to subtract. And 40 minus 30 is 10 newtons. This is not 0, so this is unbalanced. And 40 is greater than 30, so it's going to go in this direction. Okay, these are pretty much the same as 1, 2, and 3, so I'm going to skip down to 7 and 8 just to show you how to do it when it's missing a force. All right, these are very simple, and you can do these on your own as well as the back once I'm done with these two. All right, number 7. What would the force have to be to move the box to the left by 15 newtons? So we want the box to go in this direction by 15 newtons. All right, so you can write an equation. You don't have to. It's just pretty much simple math. All right, so I'm gonna show you my way, and you can do it your way. I'll do a different way on number 8. So what I'm first going to do is that I know I want the net force to equal 15. So 15 is equal to whatever these two are minus 60. All right, so 30 plus whatever x is minus 60. And then I'm just going to get all of my numbers on one side, just like math. So this becomes negative 30 plus 15 plus 60 equals x, because I moved these two on the other side of the equal sign. All right, negative 30 plus 15 is just negative 15. So I'll do those first. And then negative 15 plus 60 is 45. So 45 is equal to x. Now I want to plug in and make sure that this works. So my answer I got was 45. So now let's do it the way we would if we were calculating net force. So 45 plus 30, we have to combine those first. That's going to be 75. I have 75 in this direction and 60 here. Well, I do have to subtract. So 75 minus 60 is 15 newtons, and it is 15 newtons to the left because this 75 is greater than 60. So this is our final answer. In this one, on number 8, I'm going to do it a little bit different. I'm just going to use my basic math skills. Feel free to do them however you please. I know I want the box to move in this direction by 25. All right, so that means whatever this is, well, this subtracted from this has to equal 25. Well, I'm just going to take 25 from this automatically. So 250 minus 25 is 225. That means I need this, the entire thing, to be equal to 225, because 250 minus 225 is going to be 25. All right, so once again, I may have went too fast. I want this side to equal this subtracted from, I want this side to equal this subtracted from this. I want it to be 25. But I need these two together to equal 225, because 250 minus 225 is going to be 25. So how can I make this 225? All right, so 225, which is what I need it to be, minus 100, what it already is simply 125. There's a different way you can do it. If you looked at it and you got the numbers, by all means, that is fine. I'm going to double check to make sure I got my math correct. So here's 125. 125 plus 125 is 225. And 250 minus 225 is indeed 25 newtons. And it is going to move to the right because 250 is greater than 225. Okay? So now you need to complete the remaining problems and also the back. All right. So here you're going to be circling the correct answer for the given scenario right here, and here you're calculating net force the same way that I did on the front. Once you are done, please turn this in to me, and then you will pick up your Battle Boxes handout that I have at my desk. All right.